Welcome to another video on my channel. I'm happy that you're here, and I hope you'll actually come back to see other educational content. So for this video, we're going to be exploring the distributive property. And even if I said the distributive law, they're actually speaking of the same thing. Now, this is a very interesting concept that is not only used in mathematics to solve problems, but it is also used in our day-to-day activities in various situations. All right, so I'm going to go through this, so don't worry, you have a good understanding by the time we are through. All right, so before we reach into this this generalization right here, let us look at a real life scenario. Don't want this to scare anybody. All right, let's use a real life example. Let's consider a set of students in a class, right? And they are about to get a test. Now, you're supposed to know the regular procedure that is carried out before the administration of this test. Simply where the teacher goes around the class and issue a paper to each student. So in this case, we have 4 students right here. All right, 1, 2, 3, 4, and the teacher. So it's actually test time. So in this distribution, well, in this process, the teacher will actually distribute the papers. All right, so the teacher will distribute the paper to the student. So each student will get a paper. So this student will get 1 paper. This student gets a paper right here, and a paper right here. All right, 4 papers. Let me draw them. All students will get a test paper. Now, what the teacher did was to issue the papers, share the papers, or also distribute the papers. All right, so the teacher distribute, yeah, S-T-R-I-B-U-T-E, right? So the teacher basically distribute the papers. Now, from this word distribute, there are several other words that can be formed. Specifically, we're going to look at distributive. All right, so distribute is basically the root word, and then we form the word distributive from that. And if you remember the topic of this video, which is the distributive property, it has the same connection as the word distribute, right? And in the distribution process, the teacher actually issue or distribute a paper to each student. So when you hear of the word distribute, you're thinking of handing out, giving out, sharing, distributing, etc. So this is where the distributive property comes from. All right, so the topic is the distributive property, right? And remember, if it's a distributive law, they're speaking of the same thing, and it's basically a process of giving things out. So teacher give a sheet of paper to each student. So that's a basic example of how the distributive property is actually applied. Now let's get a bit more mathematical now, so you can hit closer to home. All right, so the distributive property of multiplication, we're gonna go through this. Why it says multiplication states that A, open bracket, B plus C is equal to A times B plus A times C. I'm going to explain this into detail for you so you can understand. Right? So the distributive property also works with variables. These are unknown values. So when you think of things like X, Y, any letter that you don't know the value for, can be M, can actually be any letter straight down to Z. Right? So the distributive property also works with variables or numbers separated by addition or subtraction sign. Alright, so recap. Distributive property of multiplication. I'm going to go through this. Right, the distributive property also works with variables, that's basically unknown values, x, y, m, etc. in a letter, or numbers. We can also use the distributive property on numbers separated by a subtraction or addition sign. We're going to do several examples of these. Last sentence, the distributive property or law involves multiplying each term in the bracket by the term outside. So the distributive property involves multiplying. So that's why it is called the distributive property of multiplication. Because whenever you distribute the outside term by the inside to each inside term, you're going to connect them by multiplication. Alright, now let's go back to the scenario before. Alright, remember, teacher out here, students in here. So let me erase. Let me erase these. What you could do is think of the students as being, let me change the color of this, as being in a group by themselves. Alright, so students in a group by themselves because they are the set of students, and then the teacher is the teacher, the only teacher in the class. So he is actually in the group, in the teacher group, right, and they are in the student group. So let me use these brackets to just kind of separate them. And remember, the process that we did was a paper is given to each student, right? One paper to that student. The student gets a paper. I want you to remember this one, it's important. This student gets a paper and this student gets a paper. So the teacher stood on the outside of the brackets here and distributed the papers. You're gonna see how this comes in helpful. Alright, if we look at this now, the A right here would be the teacher with the papers, right? And the B and the C would be the students in the class. Remember how the teacher issued a paper to each student? Now this is basically the same thing, right? So basically in this now, the teacher issued the paper to each student. So mathematically we do this. The A, which is acting as the teacher, is going to connect with the B, that's the first student, and the A as the teacher is going to connect with C as the second student, right? And if that is the case, and it is distributive property of multiplication, we connect it by using this multiplication sign. So A to B would equal to A times B, right? And this plus sign right here, it stays, right? And then A, as in teacher A, to student C would be A times C. So that's basically the same thing that we have right here. So A times B, A times C. Alright, remember, teacher on the outside, students here on the inside. Teacher gives a paper or distribute a paper to each student in the class. Alright, so I hope that you're getting a better understanding. And you can always go back to the video and get a refresher or a recap or anything like that. So we're going to do some mathematical examples now. So we left from our real life situation that you can more relate to more mathematical concepts. Alright, so we're gonna use the distributive property. Alright, use the distributive property to expand the following. When you expand something, you make it bigger. Alright, make bigger, or you increase size. That happens in expansion. So when you're being asked to expand using the distributive property, you're basically going to expand the expression and make it bigger. All right. Remember the example that we use now. The students are in the bracket, but in a group by themselves, right? Which is mathematically in the bracket right here. And the teacher is on the outside, which is the 2. Remember, the teacher had to distribute the paper to each student based on the scenario. So we're going to do this. So teacher to student 1, or teacher 2 to student 5. So this basically becomes 2 times 1 plus 2 times 5. Remember, your addition sign remains. So that's basically, when they ask you to expand, you just expand it and leave it like that. So that's basically the expansion. Wasn't hard, was it? Good. And your outside number can either be on the left hand side or the right hand side of the bracket. Whichever side it is on, the same rule applies. So we're going to do 4 times 0 first, and then 4 times 7. So this is equal to 4 times 0. Your minus sign remains, minus 4 times 7. Very straightforward, nothing to confuse you. Alright, looking at number 3 now. Remember, we said that we can use the distributive property on both numbers and variables. So number 1 and 2 are strictly on numbers. Now number 3 and 4, we have an unknown value in it. The same rule applies, right? So we have 5 open bracket, x plus 2 close bracket. Same rule applies. 5 to the x first, and then the 5 to the 2, right? So that is 5 times x plus 5 times 2. Pretty straightforward. Alright, moving on to number 4. Same thing. M to 8 and m to 2. Now, the most logical thing to do right here would to write m times 8, and nothing is wrong with that. You can definitely write m times 8 minus m times 2. But if it is a case, right, you can also represent this in a different way. You could have also had 8 times m minus 2 times m. The order does not really matter whenever you multiply, and we'll go over that concept more formally in the future. Because if you have 2 times 1 and 1 times 2, your answer is at the end of the day 2. So 8 times m, or m times 8, is actually correct. You can use them interchangeably. Alright, so let's move on to another set of examples, and I refer to this as part 2. So calculate the value of each of the following. Alright, let us get into this now. So when I ask about values, normally we go specifically to wanting a certain number, right? Like a numerical value. That's basically what is being asked here. So we have 2 ways in which we can find the value of these. Alright, I'm going to use M1 as method 1 and M2 as method 2. 2 ways. So we're gonna do 2 solutions for each. So we're gonna have 8. So I'm doing a lot of examples so you can see this over and over again being applied. So M1 now, method 1, is where we use the distributive property. Alright, so 3 times 5 plus 3 times 2. We went through that several times. 3 times 5 plus 3 times 2. Alright, equal. If we were asked to expand, we would leave it right here. But we were asked to find the value. So we need a numerical value. So after you reach this step, you're going to go further down and carry out your computations. So 3 times 5, 15, plus 3 times 2, 6. Alright. Next step, equal 15 plus 6 gives us 21. That's method 1. Hope you're getting this, Plan to make these things extremely easy so you can understand. Let's look at method 2 now. Method 2, if we should bring back our problem over here. 3, 5 plus 2. This is method 2 now. I want you to know both methods. That would make you more versatile when solving these problems. Method 2, in this case, we do this. We add the numbers inside, and if you have a subtraction sign there, you subtract the numbers inside. So we do that first. So equal this 3 on the outside, 3 bracket 5 plus 2, 7. Alright, and then this is equal to 3 plus 7, 21. So those are the two ways in which we can find the values of these problems. Alright, so pretty straightforward. And we're going to finish up the other examples now so you can see what is happening right through. Good. Okay, so method 1, use it. This is the distributive method. Remember, wherever the 5 is, it doesn't really matter where the 5. Alright, so let's go ahead now. Equal, remember, 5 times 9 first and then 5 times 4. 5 times 9 gives us 45, minus sign remains, minus 5 times 4 gives us, wait, let me do the right thing. Then put the 9 times 5. Alright, minus, right, 9 times 5, or you can have your 5 times 9, just the same. Minus, right, minus 5 times 4. Okay. Value finding equal 5 times 9, 45, minus 5 times 4, 20. So your value is 45 minus 20, which gives us 25. Alright, that's our value. And now method 2, same thing. Several examples so you can see what's happening. You're going to minus your 4 from your 9. So 9 minus 4 gives us 5. You still have a 5 on the outside. So 5 times 5 gives us 25. Alright, moving on to number 3. Now this should be looking quite easy for you. Alright, so let's go. 2 times 12, then your 2 times 3. 2 times 12 is 24, plus 2 times 3 gives us 6. Alright, so this is now 24 plus 6 gives us 30. Alright, I skip out the other part. So method 2, 12 plus 3, 2. We add 12 plus 3 gives us 15. times 2 on the outside. That gives us 15 times 2, 30. So you see the pattern, it doesn't matter which method you use. Once you apply it properly, you get the same answer. Alright, 30, 30, 21, 21, 25, and 25. Alright, so I just want to point that out. So the last one now, number 4. 4 open bracket, 20 minus 5 close bracket. Alright, so first method, 4 to the 20, 4 to the 5. Remember, same thing as the teacher-student analogy that we used. Teacher is on the outside, distribute the paper to each student inside the bracket. Alright, so this is equal to 4 times 20. We're going to put it 4 times 20 minus 4 times 5. Alright, 4 times 5 equal 4 times 20 gives us 80 minus 4 times 5 gives us 20. And 80 minus 20 gives us a 60. Alright, so straightforward, nothing to stress you out. Method 2 now, 4, 20 minus 5. Do whatever is in bracket first, right? So 4 is on the outside bracket. 20 minus 5 gives us 15. And then 15 times 4 gives us 60. Pretty straightforward, nothing to stress out anybody. Remember, you can always come back to the video and get a refresher course, or also to just practice the examples that I did here. Alright, so this video is actually part 1. I'm going to be creating part 2 and I think part 3 that will move deeper into the concept of the distributive property when using it to solve mathematical problems. Alright, so thanks for visiting the channel. Please remember to subscribe, share the channel link with families and friends so that they can also benefit from the good content that is here. And if you have any questions or comments as it relates to anything that is in the video, you can leave it in the comment section and I will be sure to reply as soon as possible. Alright, so look out for part 2.